All right, so we're going to check homework from last week. This is the Pythagorean Theorem worksheet. Um, for those of you that haven't done it yet, if you're watching this, you'll just do your best to follow along. You will get only partial credit if you turn your homework a little late, just because I'm posting this video. Um, but definitely worthwhile to just figure out what's going on, right? So that's the most important part, is just knowing what to do. So let's get started. So we're doing just the evens. We're going to check number two. Number two gave you this triangle. It's a little bit like this: 12, 5, and 13. Now, the question is, do these form a right triangle, right? So we actually don't know if it's a right triangle. So you do have to use the Pythagorean theorem to verify it. And because you don't know if it's a right triangle, we obviously don't know where the right angle is. But remember that C, the hypotenuse, is always the biggest side. So for this to be a right triangle, 13 would have to be C, because that's the longest side. It's the biggest number, right? So if this was a right triangle, it would have to be set up like this. This is going to be A, and this is going to be B. So automatically, we know 13 is the longest, right? So we check 5 squared plus 12 squared would have to equal 13 squared if this is the right triangle, right? So 25 plus 144 would have to equal 169. And lo and behold, that is true. So number two is yes. All right. So key thing there, right? You do have to make the biggest side C. That's just part of how a right triangle works. Okay. For those of you that switch these numbers around, that wouldn't work that way, right? So the Pythagorean theorem wouldn't hold true because you're not setting the longest side to be C. All right. Let's do number four. Number four is going to be a nice and easy one, because 3, 4, 5 happens to be always a right triangle. Whenever you see 3, 4, and 5, you can start to memorize that that is always going to be a right triangle. And we can verify that real quick, because 5 is the biggest number. That one's going to be the hypotenuse. So we just write our Pythagorean theorem real quick, and then 19 or 9 plus 16 equals 25. So 3, 4, 5 you can start to memorize as a right triangle and not have to do work for that, really. Number 6, we've got it already sets up for you what A, B, and C are. So at this point, number 6, you're just plugging in things into your calculator. And I say calculator because you've got decimals here, so this is totally fine to use in your calculator. 2.1 squared plus 7.2 squared would have to equal 7.5 squared. And it holds true that this is a right triangle. So just plug that into your calculator. Nothing fancy going on here. This is also a right triangle. Cool. So that was the first three. Those you were verifying it's a right triangle. The next three are kind of like the lesson where you're just looking for the missing side, right? So let's do number 8. So these we know are right triangles, and we're looking for the missing side. So here we have the verification of a right triangle. Across from it is the hypotenuse, right? So this is C right here. That means we have A and B given to us. And remember, that's because the longest side is across from the right angle. So now we have 3 squared plus 6 squared equals c squared. That means 9 plus 36 equals c squared. C squared equals 45. So we do have to take the square root. And then c equals the square root of 45. Now, I know the worksheet told you to round to the nearest tenth. My mistake. I didn't catch that. So, like I said, if you've seen the videos, you always want to keep it in radical form, in exact form. You don't want to plug into your calculator around. So, if you put that into nearest tenth, that's okay. Obviously, that's okay. You were following directions on the paper, but just remember that even if there are mistakes that say that, just keep it in radical form. So we're gonna look at this square root of 45 is going to be 9 and 5, which is just 3 square root of 5. So this is our final answer right here. All right, so final answer is here on the left. It's 3 square root of 5. Okay. Number 10. So we have our right triangle and our right angle given to us. This means that C is over here, and then we have A and B for 3 and 7. So that means 3 squared plus 7 squared equals C squared. That means 9 plus 49 equals C squared. 58 equals C squared. Only thing left to do is take the square root. So that means that C equals the square root of 58. And you're going to leave it like that. If you try, to go through the perfect squares to simplify this, it doesn't work out, right? So this doesn't go into anything. So 58 is not divisible by 4 or 9 or 16 or 25 or 36, right? And that's pretty much, and obviously not 49. So so that doesn't work. So that's your final answer. All right, last one. So all of these, as you can see, all of these, the hypotenuse is missing. So we have our right angle and our hypotenuse is across from, so that's the unknown side. So let's set this up. 2 squared plus 6 squared plus C squared. 4 plus 36 equals C squared. And a nice even number here. 40 equals C squared. Take the square root. C equals square root of 40. If you look at that, you can pretty much just, always guess and check, or you could see that 40 is divisible by 4, and 4 is a perfect square, so that works out really well for us. So you can do 4 and 10, and then obviously square root of 4 is 2, and square root of 10 cannot be simplified further, so the final answer is 2 square root of 10. And that's that. So hopefully this made sense to you guys. Again, just make sure you're soaking in how to use this theorem. One of the most important equations you'll ever learn in math, right? So um, just get it down as best you can. Do other problems on that worksheet if you need to, and that's that. Thanks for watching.